All right, it is 12:30, so I'm going to go ahead and get started. This is going to be the penultimate final exam review. I will be holding one tomorrow on Zoom only. Um, this session will be recorded and will be published so that you guys can view it afterward, as well as to all those who aren't able to make it. Um, so what so the format of this is going to be different than what Parker did last Friday, in which this is going to be really just an Ask Me Anything type session where you guys are going to be the drivers of what topics we get to cover today. And that goes to all those who are joining us via Zoom. So, yeah, what would you guys like to cover? Yeah.
Can we go over drawing like heap and stack, like in that model?
Yeah, for sure. Memory models for heap and stack. I'm gonna move this chair out of the way. This presentation podium is both too short for standing up, but too tall for me sitting down. I said short. Anyway, but yeah, heap and stack model. So yeah. So heap and stack. Now, how much of this were you able to cover in lecture? I have not been able to attend lectures this semester, so I would not know.
Basically what we covered was like immutability,
Mhm.
and also how like primitive types are stored directly on the stack.
Mhm.
And like there's references that are also on the stack, but they point towards your heap.
Okay, so basically how the Java memory model works.
Yeah.
Okay, so yeah. Then yeah, that is pretty interesting and pretty important to know. And this heap and stack model is actually used by basically every other programming language as well. As object-oriented type languages use this type of thought process too. So, but basically all you need to know is that memory is just a big ol' array of numbers. So basically, it's up to kind of the programming language or even the user, depending on which programming language you're running, to decide where does data go in this. And each program tends to know where all of its data is. So going back to Java, we have the heap and we have the stack. The stack is where all of our primitive types go, and the stack grows, especially depending on what method calls we're making. So the stack just grows down as we stack always grows from the top down as we add more variables in, add more data into the stack. And you are right. All the primitives and basically the variables are being stored here. So I'll just say variables. So basically anything that is stored in a local part of your program is being stored in this region of memory. And by locally, I mean local to whatever method you are running. You don't have access to the local variables outside of that method, unless you are willing to break Java. The heap is a different region of memory that allows us to basically get some memory locations and store data in there. And then we can add something else somewhere else. This is where all of the object data goes. So a variable will always point to somewhere in the heap. So, any questions on that so far? And I am focused on those who are here in person, but if you guys want to go ahead and use chat to reach out to me, I will try and make sure to keep an eye on that. But yeah, what questions are coming up as I've gone over this? Yeah.
You like go through a method and like update it? update the memory model of the stack and lead.
Yeah. Do you have an idea of what this method might do? Just kind of a foo? Just kind of a generic method,
Yeah.
doesn't really matter what it does.
See how the-
Yeah, for sure. So let's so let's go public void foo. And it takes, and if it does take some variables as a parameter, those also get added onto the stack. But say if we declare int I equals 0, that's going to get added onto the stack. Then next we're going to say, let's make a list. So list, we'll make it a string of strings. String li equals new array list dot dot dot. I'm not going to finish out that, mostly because I ran out of space. But li is going to be something that is on our stack. So this is on the stack. And so li is going to be what's in our stack, and then this new array list object is actually going to be in our heap. And it's going to take a reference and store it in li. So does that help give you the basic idea of how that might be used in a method?
Yeah.
Okay. It's not something that's going to be too huge until probably later in your programming career. But it can be helpful to at least know the basic ideas behind it, especially in terms of object-oriented programming. Yes.
So is the variable I on the stack and 0 is
0 is, so remember, this is a primitive. Its data is stored the data related to any primitive is stored directly in the variable. So actually 0 is, I is just going to be some location on the stack, and what is in that location on the stack? 0. Absolutely. Great question. Yeah, any other questions related on this, or is there another topic that you guys would like to go over? Yes.
If you go to the abstract data type again,
Yeah, abstract data types. Yeah. All right. So abstract data types. So for our purposes, and any abstract data type, examples of that could be list, set, map, and in Java, what do all of these feature when we're declaring these types to exist? I'm just going to go ahead, angle brackets, T, angle bracket, T, angle bracket, K, comma, K, comma, V. So abstract data types are basically saying, hey, I'm going to try and use any type I can and my implementation doesn't matter if the type is a string or an integer or a foo or a bar. It truly does not care, so long as, and often for these types, sometimes there are restrictions applied to them. So for lists, I do believe you need to have comparable objects so you can sort the list. But for other objects, but for set, it probably doesn't matter if you have it sortable. There is no order to a set. Yes. Yes, so, yeah, I'm not sure what you guys were reminded of in what you guys were told in class, but the way I would put abstract data types is basically ADTs are types specified such that they can with any other type used inside. That's probably the way I'd put it. Does this make sense, or does this seem either lacking or wrong based on what you guys have actually talked about in lectures? It makes sense? Excellent. So, what other questions do you guys have on abstract data types? Yeah,
How do you use them?
how do we use a map? Okay, yeah. So remember that a map takes a key and a value, where the value is based on what the key provided is. So if we say map string integer, and I'll just call it map, say I can set it equal to a hash map. And Java, I know later versions of Java do allow you to do this, where when you're calling the constructor for a new abstract data type object, you can neglect neglect the contents of the caret braces. But basically, anytime I need to use a map, I can say, okay, map dot put, I'll put foo in as a string and a value as 47. So in the hash map, foo is going to be how I know foo is going to refer me to some sort of value. And the value that we're associating with foo is 47. And then if we're going to get map dot get, and this could be wrong, please make sure you double check with documentation according to whatever language you're using. But if I put foo, this should return 47. So but that's the basic idea of a map, is if you have a key, you can get a value out of it.
You have to set it equal to hash map?
Yes, because it is an object that you're creating. I am referring to the map in the generic interface sense, and then I'm using a, oh, what do you know? I made an error. I forgot my new keyword. But I am referring to a map. I'm storing a map object in a generic variable, but I am using a specific class that can be instantiated to place into that variable. So I am actually using some abstraction here, because HashMap does have more features and a different implementation than, say, a tree map. But it's all being used as though it's a map. It does not matter what functionality. I could say it's a tree map if I wanted to, and it would still work the same according to how I'm trying to look at it. Yeah, any other questions on that? Yes. A set. Ah, yeah. So this is something that I think you generally will get more into with other classes if you are a computer science or computer engineering major. A required class is CS 2100. I think you can replace it with math 2200, but don't quote me on this. But in CS 2100, you do learn the functional differences. But to sum it up, a list has an order. So a list, remember array list, you can access based on an index from 0 to length -1 and it will always get the same items in that order. And it also allows repeated values. I can add foo multiple times into a list. A set is not explicitly ordered. And there is no repetition. So if I were to add foo into a set of strings, once foo is in there, I can try and add it, but the size of the set will not grow. Does that make sense? Okay, so that's the difference you guys need. So those are the major differences that you guys need to know. And then more is discussed in that CS 2100 discrete structures class. Yeah, what else do we want to look at? What topics do you guys want to consider? Yes. Comparable versus comparator. All right. Yeah, let's absolutely take a look at that. That can be a pretty confusing thing. So comparable, in what instances did we use comparable in this class? Can somebody just shout out an instance we used it? And you can do so on chat too.
I believe it was in one of our assignments
Mhm.
that, it was the Gaussian game assignment.
Mhm.
There was like a tool that had a certain power level.
Yeah.
We used comparable to see which, like, if there was two tools and you compared which one had the highest power level.
Yeah, so we're comparing tools to each other. So we're comparing tools to each other and establishing a natural ordering of those tools. So comparable, I'm gonna separate this out. So comparable tends to use natural ordering. From class, what's an example of natural ordering that we've used? Yeah, there's that funny word that starts with an L. Lexicographical ordering. Need to make my H not look like a B. Something like that.
That just use like ASCII values to.
It uses alphabetic ordering. So it's the idea of using alphabetic ordering. A words come first, then B words, C words, and so on until you reach the end. Graphical. Got a P in there too. Okay, so lexicographical for strings. Yes.
And also, how do like lowercase and uppercase letters compare?
That is something I would actually invite you to just write a small experiment code with. I can't say I know for sure, but this session is mostly just to review the overall topics. I'm not going to spend a huge amount of effort in starting Eclipse on my computer. Yes.
Actually, that's that question, because, if it's numbers, then capital letters, lowercase letters, and then numbers. Thank you.
Okay, that is great to know. So yeah, natural ordering. So yeah, natural ordering, lexicographical for especially strings. Yeah, so comparable uses a natural ordering. We wanted magic items first in the gotcha game. Then it was, I believe, armor and then items. So that's what I remember. Please correct me if I'm wrong. So that's the basic idea of comparator. We had natural ordering where we wanted things in a specific order based on what that item is. So comparator, in contrast, does not require a natural ordering. You can establish your own ordering however you want. Yeah, so I believe it was in a lab where we used comparator to establish ordering by GPA. That wouldn't be a natural ordering according to how, that's not a natural ordering according to student last name. Maybe a more natural ordering would have been by student last name. You can also ordering by their university ID number. Ordering those students in that way, where you can order them however you want to. It allows you to order however you want to. Yeah. Does that help answer the question of the major differences between comparator and comparable? You have a question? Okay, then yeah, if you don't have a question, we can move on. Are there topics you guys want to cover, or do you guys have any questions regarding this? Yes.
Talk about like the purpose of nested classes, like
Nested classes. Mylan, could you make sure that your microphone is muted for me? Thank you. So yeah, nested classes. So yeah, just call out some instances where nested classes were used in this course. Oh, got a chat. Nah, no worries. Yeah, where are some instances? Yes. Yeah, comparator. We made some comparators as nested classes. Are there any other instances where we use nested classes in this class? I think comparator was the most major one that we did use. So yeah, comparators are a pretty big example because comparators don't necessarily belong to something other than the class that they were designed for. So like for student, we had the order by GPA comparator, or we had the order by ID number comparator. So yeah, these are pretty major because they always belong to the class. They come from, or they are in. Yeah, any other questions you guys want to ask about this? Yes.
So inner class is a non-static.
Yeah, an inner class is a subset of nested classes. So an inner class, yeah, tends to be a non-static. Yes.
How do you like write like a pattern for.
A nested class, it's going to be pretty similar, but it is going, so say we have a class called foo, so like class foo. And then inside that, we'd probably, it's going to look very much the same. Public class bar. Yeah, there's not, I would say there's not a huge amount of instances where you need to use nested classes. But this is the basic idea. And then obviously, and then if like there are some errors that come up from your compiler, your IDE should let you know about that. I know Eclipse has done so, as well as I'm a big fan of IntelliJ, so I know how that one would give you a pretty good idea of what kinds of errors there are and maybe even how to fix them. So IDEs are going to be your favorite tool in terms of making these correctly. Samantha just asked a question. What are some real world examples where we might use nested classes versus just having a separate class? That is, so going back to having comparators, Samantha, comparators are probably one of the biggest ones that I am aware of. I haven't done very much with nested classes myself, but comparators are going to be the big ones. Just because they are just because you want to have a comparator that should belong to your class. So like with student, ordering by the GPA, ordering by the student ID, that doesn't make a lot of sense to belong to anything else. But if you were to make it belong to the class, make it belong to the student class and have it be an essay class there, that's more useful, especially because it makes writing the class variables easier. Does that answer your question, Samantha? Okay. Yeah. Other questions? Yeah.
Go to like, how to use Lambda expression.
A lambda. Yeah, absolutely. We'll go to a new page. Lambda expressions. Absolutely. So a lambda has the syntax of insert whatever variables you're going to use with the lambda. So I'm gonna make it a closed set of parentheses. These are basically parameters. And then you use the syntax of a hyphen and a right-facing caret. And then we declare a curly brace to insert an expression. Or well, really, some lines of code. Of code. Oh. Yep. So this is the basic syntax where we have parameters that are going to be used within a lambda, and then we can put in any amount of lines of code that we need. This forms, given that these are curly braces, this is a scope. So you can use it in whatever, you can have as many lines as you need in order to make that happen. Generally, you want to avoid putting too many lines in there. Otherwise, you will just benefit from writing a method to do the work that you're intending with the lambda expression. Lambda expressions are just helpful in putting into making something that needs to be run into basically its own object is probably how I'd put it. Yes.
Can you store this expression like a variable?
Yes, I believe there is a way in Java to do that. That's not something we've talked about in this class. And that is, I would also say it's more advanced than this class covers. Yes. Yeah, for sure. So let's take the instance of doing a JUnit test where we're trying to make an exception be thrown. So we're saying assert throws. And then I'll say it's a class here. We'll just take some exception class here, and then here I'm going to say, let's see. Let's take, what is an example of a line of code we've used in class that has the potential to throw an exception for us? Yeah. So, okay, what's a line of code that you've run that has thrown an illegal argument exception? Yeah, we could absolutely put the whole thing in of throw new. Yeah, we could absolutely do that, but that test code that Java has already written and has thoroughly tested before release. Obviously you would want to do something that is a you'd obviously want to do something that is in code that you've written that needs to be tested. But this is an example of something that you might put into a Lambda where in an assert throws, when you're writing JUnit tests, you want to assert that you can call a constructor and say, hey, this should be throwing an illegal argument exception on us. So does that help answer your question about potentially using a Lambda? Yes. Yeah, let me see what I can come up with. So trying to I think I'm trying to remember other ways that I am using that I've used lambdas. Let's see. Let's go. Okay. Here's an example that you guys may or may not have used, but if you have some list, let's say this is a list that has already been declared and been populated. There is a function on lists that is called for each. So li dot for each. And this basically will do a for each loop on your list. And then you have to populate it with something to run. So here, we need to make a parameter to use inside the Lambda. I'm going to call it n. And then I'm going to populate it with, I'm just going to call it print. This would be a system.out.println. But that would be that's something that you could do on that would be an example of where you'd use a Lambda expression outside of the assert throws in a JUnit test. Is that an example that you think might be useful? obviously, like, I think it's easier to just write for each loop, so for integer n in Li, and then do stuff. Do stuff. And then obviously, I think this is a little bit easier way of interpreting how a for each is being used. But this and our lambda expression here are essentially the same idea. Yeah, absolutely. Let's go ahead and go back. All right, yeah. Any other questions you guys want to go over? We still have a little bit less than an hour, so the time is yours. Yeah.
You maybe walk through, like,
Oh yeah, enums. Yeah, for sure.
like,
Okay. So, um, I'm a computer engineer and I've used the C programming language a lot. I would say probably the way an enum might be used is basically you want to say that you want some specific values to, I guess, be more human readable. So take for instance your paint assignment where we declared an enum called shape, where you likely declared an enum called shape. So enum shape, and then line. Then let me go ahead and indent those. So that's the base. So this is the instance in which you used an enum for your paint assignment. Where we basically said, hey, we've got three possible shapes and we want it to be limited to these shapes. So an enum is basically saying, hey, I want three distinct things to be considered here. And I want to associate them with one is a line, one is a rectangle, one is an oval. So the idea is that behind the scenes, these are basically just numbers. So this might be 0, this might be 1, this might be 2. And you can obviously expand the enum to include however many shapes you want. But it's just represented by a number. And then what you can do is you can even use a switch statement. So switch shape. We'll say that's the name of our shape enumeration that we're keeping track of. And then you can the case would be just one of the enumeration names. So this is a pretty decent way of checking of using something that you can. Enums are basically a way to make things a little bit more human readable, because instead of saying case and having an integer to keep track of all the shapes you're using, where 0 is 1, 0 is a line, 1 is a rectangle, and so on. The enum keeps track of that for you and basically assigns that such that you can read it as you're writing the code, and then as it's compiled and as it's run, the computer can just think of it as a number, but it gives human readability to your code. Yeah. Samantha in chat has a question. What are some examples in applications where we would use recursion, and what are some steps we can take to solve a problem with recursion? So there are a variety of different methods that we can use recursion on. One of my favorites is actually a type of sort algorithm called merge sort, where we basically say, okay, we're going to split an array into two. So we have an array here. We're going to split it into two. So we have two arrays, and we're going to sort these. The easiest way to do that is to actually do this in recursion, where we split it into two and then we call our sort recursive method on a smaller set of this array. And then we do that until we have our base case. And then as we go back up, we merge it back in as a sorted. So to go through a recursive method, what are the two, I think there's two major things that you need to do in a recursive method. So we'll call this method recurse. I'm not going to spend the time doing things. What's a major part of a recursive method? What's one major thing that needs to happen? Yes. Base case, yeah. We need to make sure it stops, otherwise we actually get Stack Overflow. So we need to have a base case to basically say, this is the moment where I've recursed far enough and I need to stop. And then we need to define the recursive case. So what are some examples that we've used in the semester of recursion? Binary search. Okay. And what's the base case? What is a base case for a binary search? Okay, so let's say, one base case for a binary search is target located. What's another base case? There are technically two base cases in a binary search algorithm. If we've divided the array up enough times that we basically have the array so much that we should be looking right at a target and we don't find a target. So no found. So I'm going to say no target found where expected, because binary search does work on a sorted array or a sorted list. So if we don't find a target at the expected location, so let's take the example of an array of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's take this 10 element array, and we're going to call binary search on it. So let's at least just walk through how the binary search works, just so that we can maybe see how we might use recursion on it. So we start looking at the entire array. What is the half element? 4. So we look at this. Someone throw out a random number between 0 and 9 for our target. 3. Okay. So we look at 4 and say, is our target above or below it? Since our target is below it, we're going to take this and move it here. I'm gonna erase this. So we're going to take our upper bound and move it to where we made that halfway point, and then we're going to run it again. So this is an example of a recursive case. The target is below where our target is, so we move our upper bound of where we're looking down, and then we run the whole idea again. So we have 0, 1, 2, 3, 4. What is the middle element of this now halved sized array? 2? Yes, I believe you are right. So we look at 2. Is 3 above or below 2? Above. So we take this one and move it up. And all right. So now our halfway point is technically in between two elements, but we're doing integer reduction, so it belongs right. It looks at right there. 3 is our target. This, we have reached a base case. So now we return that we found our element. And basically go up our recursive stack. So this moves back. This moves back there. This moves back there, and we return. And this is what we return. Any questions on this? In the back?
Starting off, is it either 4 or 5? Or
Yeah, it could technically be, yeah, since we started in the middle, it could technically be 4 or 5, but let's think about integer division. Do we round up or do we round down? No, we always round down. This is truncation in action. Because anything that is a decimal point, we just drop it. It's what is called truncation. So we always start at the lower if we're in between two elements. Okay, so what questions any other questions? Samantha, does that help you see some applications of a recursive method or recursive action? Okay, great. Anything else? What else do you guys want to cover in this session? Yes. Oh, so common components of a GUI in Java? Yeah. GUI. Common components. So we obviously need the main window in our Java GUI. What class generally provides that main window functionality? JFrame. Yeah. So, and then JFrame contains that, it forms our primary window. So it's probably going to look something like kind of a box. I'm thinking Windows, the X button is always on the right. It has title, and then there's probably some content here. Yeah, I would say this is probably this is the basic idea of a JFrame. All right. So the title, that's just a property that generally belongs to the JFrame. Content, what can we put inside the content area of our JFrame? A JPanel, yeah. JPanel. A content container, I'm gonna call it. So basically we can put a variety of things in here. We can put drawings. We can put buttons. We can put context menus. We can put a variety of things inside our content panel, our content container. All right. So what's an let's see. So what's a common thing that we can use as a button? Okay, be a little bit more abstract than that. Yeah, what's the name of that class? JButton. Yep, so we can create a bunch of JButtons that can perform a set of actions for us. Easy enough. All right, context menus. What is a class that you can use for that? JMenu. JMenu items go inside a JMenu. Yeah, we can have a JMenu and that can contain a few JMenu items for a save or a load. Reading stuff into, we can use that for different contextual actions of our program. All right, and then drawings, that's generally just adding elements or extending the JPanel. So extend panel. Yeah, any questions on kind of these major elements of a GUI? Are there other components of a GUI that you guys think we might want? Yeah, some labels. Yeah. Yeah, those can be added in as something that relates to one of the buttons or a drawing, just like one of the parts that's contained, yeah, text fields. Samantha, do you know the name of a class in Java that can be used for text fields? JText field. So text fields. Next field, JText field. Yeah, there's a variety of things that we can put into a panel to basically make content and write it into a GUI. So, is it very fun to write GUIs using just code? I'm gonna say no. Java is probably one of my most detestable languages for writing GUIs because there's no real like GUI editor where you can visually lay out your GUI. You basically are forced to write it into code. There are frameworks like Qt is a common one. Windows Forms is another one that is available for C#. Maui is another one for C#. If you guys take CS 3500, that uses Maui to make programs. Yes.
JavaScript. Yeah, yes.
I am not familiar with any JavaScript or any of the frameworks related with JavaScript. Again, I am very much a backend programmer. I don't deal very much with front end. So yeah, but absolutely but yeah, JavaScript and any of its frameworks. You probably want to use one of the frameworks of JavaScript because as far as I'm aware, JavaScript is actually a very weird language in terms of its syntax. It can behave very strangely. Yeah, but there's lots of options. Java is one of my least compelling ways to write GUIs, just because it is basically organized code only. Awesome. So, yeah. Other topics you guys wish to cover? We still have a little over half an hour, so I'm happy to answer any questions. Yes. Command line arguments. Yeah. I don't know how much you guys have talked about this in class. But command line arguments, basically they are like parameters that allow you to control how a program runs depending on what the program desires are. So let's see, trying to think of a program that is generally pretty easy. So, actually, let's take the ls command in Linux, Mac OS, basically a Unix distribution. So ls. This is going to list the files in the current working directory. List files in current directory. So there's so if we just call ls, by default, it's just going to give you a list of different file names. So it's just going to say, let's say src, also any directory names, src bin, words dot text. This could be an example from a project folder that you're working in Java. Now, let's say if we add the -a as a command line argument. What this will do is it will show all hidden folders. And yeah, folders and items. In any Unix operating system, this is going to be anything that starts with a dot in its file name. So like .git, .config. So, and so on. There's a lot of different, in any Unix-based in any Unix-based operating system, which includes Mac OS, Linux, these folders are hidden when they have a period as the first letter in the name of a file. If we say -l, this is going to show the permissions. Show permissions of files. So these are the basic ideas behind command line arguments. It basically allows you to manipulate it. Now, let's take it into Java. When we have main, and it takes a string array called args. This is where all your command line arguments go when you run a program in Java. If you want to use command line arguments to actually manipulate how a Java program runs, you're going to want to, I would actually recommend that you do some experimentation as to, okay, what is in args? What is contained in args? And it could be different depending on one, the IDE that you're using, and two, if you're actually just using the command line to run it too. So, but using command line args is just a way for you to, when you're programming, to manipulate how that program is used, how that program runs, like what is different about that runtime, depending on what argument you use. Samantha asked a question about final, the keyword. So final as a keyword in Java means can be set exactly one time and can never be manipulated after. So Samantha, when we declare something as a final variable, it means we are probably going to set it one time and it's never going to be manipulated. Examples of this could be a file path to a file that you are loading into your program. That at least that's one example. If you have used IntelliJ, you've actually probably received a warning about a variable that you have set exactly one time and then just never reset or manipulate. That would be a way for it could be a compelling reason if you set a variable one time and then just never change it. That could be a good instance of using a final variable. These should only be used as instance variables. Declaring a variable as final save memory. It doesn't save any memory beyond what it would be used normally, but it does make sure it basically just tells the Java garbage collector that this variable is never going to be manipulated. And once it basically, it's more efficient in the sense that it will take up a specific memory space and then never change to a different memory space. Like say if you declare a string, you're not going to be adding new memory to save a new string in that is referred to by a variable name. So it is possible that it could be more efficient, but that is something that is beyond the scope of this class. Does that make sense? Okay. I did see that another question came in. What would be the use of a constructor in an abstract class? Okay. I think we can probably do a full review of abstract classes. Are you guys okay with that? Yeah. So let's kind of just do a generalized discussion on abstract classes. Rishab, I can't say I know how to pronounce your name. But yeah, let's do that general discussion. So what are some unique features of abstract classes in Java? And just people call it out, put it in chat, and we'll add it to our list as we go. Yes.
You can't make an instance of it.
You cannot make a specific instance of it. Cannot be initialized as itself, I'll say. Okay. I think someone was going to call out something else. Yeah, he uses the abstract keyword that I'm just going to underline abstract there. Okay, let's think of the difference between an abstract class and an interface. What is something that is unique to abstract classes that cannot be used on interfaces? Uh, no one has any good ideas? I think the big one when it comes to the difference between abstract classes and interfaces, because both of those are unable to be initialized as themselves. But abstract classes can contain instance variables. and they can have methods with definitions. Okay, so these two distinguish abstract classes from interfaces specifically. So now let's think of something that is also unique from regular classes. We can also declare methods that don't have definitions. So these are kind of the major things in abstract class. I would say probably these 4 items. These are the major things that you should know about abstract classes. Interfaces, I do not believe can contain variables. If you look it up and see that something that is actually not the case, please do actually correct me. Going back to the question, the use of a constructor in an abstract class. So constructors, abstract. So remember that we can contain variables inside an abstract method. We can contain variables inside an abstract class. We can actually have variables that are unique to an abstract class. Like I think shape2D from your paint assignment, what is an example of an abstract class? So in order to initialize that, we obviously want to give values to our to those variables that belong to an abstract class. So give variables oh my. Looks like my computer has decided to give up on some part of life. And then the basic idea is that we want to give variables values in abstract methods or in abstract constructors. What other questions do you guys have about abstract methods? I am actually going to hope that my computer did not just die. Or maybe it's... How do we know when we should use an abstract class? Okay. Who has an idea of maybe a good place where we can use abstract classes? I want to open this up to you guys. I don't want to just lecture here. And feel free to just call out any suggestions.
Want like all subclasses to contain a particular method?
Yeah, I think that, yeah. So, yeah, uses. And you don't, and in the case of abstract classes, would this be a method that you'd want them all to contain and have the same functionality, or would you want to have their own functionality? Yeah, I mean, both would work because an abstract class, we can actually provide some definitions to some methods. We can also define methods as abstract and say, yeah, all objects of this class have this method, but the determination of what the function, the inner function of that method is, would be determined by whoever extends that class. So all sub have same basic function. Resub, since we cannot create instances of abstract classes, where would the constructor be used? I would say that's a place where you'd use the super constructor. Super, and then whatever variables go in there. So the constructor would be used by making a call to the super constructor inside whatever constructor you have in a subclass. Does that answer your question? Okay. So yeah, all subclasses have the same basic function. Okay. Are there any other questions, or do you guys have any other? Yes.
Can you explain the difference between partial method overriding and just method overriding?
Yes, so partial method, I know that question was asked in Parker's session 2. Samantha, yeah, just to shortly answer your question about if the constructor not being used unless you use that super keyword, yes, that is the case. Okay, so yeah, your question was on partial method overriding versus straight method overriding. So all right, so method overriding is actually something that you will actually get asked about quite a bit in interviews. At least I know I have several times. But the basic idea is some superclass declares a method that a subclass changes its functionality. That's the basic idea behind method overriding, where a superclass declares some method that a class that extends this method will actually redeclare it and say, I'm going to do something different.
It's the same.
Correct. The signature is essentially the same, minus the fact that it is explicitly for the subclass. And then in order to make it only partial, we do need to use that super keyword and access the method as defined in the superclass. So super.foo. Let's say foo is the overridden method. And in order to make it only partial, we use the super keyword .foo. So we're basically reaching up into the superclass and using foo for the instance of that. And you'd probably want to use that at the beginning. I do not believe you are restricted to only using it at the beginning of your overridden method.
Will the parameters have to be the same or?
Yes, you'd probably just feed in the parameters that you got for the overridden method. So like with paint component in your paint class or in your paint assignment, that uses super.paint component G, and that actually reaches back into the J panel. Hey, it drew the background for you, basically made sure the background was always clear. And then after that ended, you would actually be able to add some extra functionality to yours, but you wanted to keep some of that basic functionality given by J panel when you created paint panel. Yes.
You make a case where you use brick inside of the switch thing.
Oh yeah. So using break inside switch. Using break inside a switch. So break and switch, those are both keywords that are used in Java and actually multiple other programming languages. I actually wrote several switch statements on my final project really just the other day. And that was in C++. So it is a very common, those are two very common keywords, but using break inside of switch. So say you have several cases. Case 1, case 2, case 3, and then I would say we should always use the default case. Now, switch statements do have a feature that is labeled fall through. Where if I do some stuff inside case 1 and then I do some stuff in case 2, do other stuff. If case 1 does not have a break statement from its case, it's actually going to fall through and do the same stuff that case 2 does. So basically, if case 1 does stuff and does not break, it will also do other stuff as seen in this case 2. Do you see how does that make sense as to maybe why that happens? Or maybe you are confused and you have questions.
Also, if I don't have the bricks in the case, it's not. This
Yes.
also perform.
Mhm.
Do other stuff.
Yeah, if I don't, yeah. In this, I have case 1 where it does stuff. And if I don't include break, it falls through to case 2. Sometimes you do, so break is included such that you can do things for multiple cases. So say I do actually want to do stuff with case 2 because case 1 and case 2 here have functionality that you would want to say you want to do the stuff for case 2 on case 1 as well. Having break gives you the option to either not do that or to allow that. Yeah, does that help you answer your question?
Yeah.
Great. Yes. Yeah, so yeah, you can it could be similar to doing a string of if, else, if, or just if, it would probably be similar to doing if and if without any else's. Switch statements are actually, this is something you learn later in a coding career, especially a CS degree, where switch statements, when they are compiled into runnable code on when they are compiled into runnable code on a system, they actually do run faster than if statements. If has a lot of overhead when converted into how a CPU actually will run the unique instructions. But a switch statement, especially large ones, will have ways to make it leagues faster. This is not something that I'm going to cover today just because it would get very confusing very quickly, and you probably want some of the extra information that are provided by classes that you would get before this class. But if you want to know why, there is a class CS4 4400. This is entitled Computer Systems. This class will delve into that topic. I don't want to get you guys too confused, especially as that kind of thought process doesn't matter going into your final exam. You guys really should make sure that you understand just the concepts that are presented, that have been presented in lecture, and then you can worry about bigger functionality through further classes. Yeah. Other topics you want to cover, we do have about 10 minutes remaining. But I will make sure that this recording is available after this session. So that you guys can review it afterward. Yeah, but other questions you guys want to cover while we still have time today?
Immutability.
Immutability, yeah, that's a good one. I'm gonna make a new page. Yeah, so immutability, what do you remember about immutability?
Well, there are certain, like, I guess, reference types that.
Mhm.
Well, I guess I'm confused, like they can't change.
Yeah, after a object of that type has been initialized, it cannot be changed. Yeah, absolutely. So cannot change state after, I'm going to say creation here. So is there an example class that you remember that has this feature?
Um. Well, what's like you can, so they said that you can like add, like if you have a integer wrapper class, right?
Yeah.
Like integer number equals 3,
Mhm.
and you like number equals number plus 1. So how does that have to do with like stack and heap memory? Like,
So, oh, okay. Yeah. So you're kind of wondering how immutability affects how you use your stack and your heap.
sure, yeah, how does it
Okay.
affect?
Okay. So let's take strings, for example, because strings are probably the most famous example, in my opinion, of an immutable class. So if we wanted to say string s equals USS, and then what I wanted to add on to that, so s equals s plus space enterprise. S is actually not going to get directly affected. You're going to combine S and this constant string and actually create a new string object and put its reference into S. So let's put a little bit of space. Say we have S here. This little box is going to represent S. And we're in the stack here. Now, I'm going to let the rest of what is on screen here represent the heap. So when we create USS, we point somewhere in the heap. That's it, USS. And then a bunch of other things. Basically other things that relate to the string USS. Now, when we add to that, we're going to, a constant string is stored somewhere else. I'm just going, it's stored in a different place in the heap, or sometimes in a constant, or sometimes in a place of memory that deals specifically with constants. It's not always stored, it's not always added in directly from where the instruction is. But when we do add this string and this string together, we actually create an entirely new string, USS. we create a new string and all of its associated functions, and then we erase and repoint our reference inside the stack to the new place in the heap. And then sometime later, the Java garbage collector will come in and say, hey, nothing points to this. Okay, I'm gonna get rid of it. And it frees up that memory. It does it automatically for you in Java, which can be actually really helpful. If you've ever run modded Minecraft, especially, you'll see that sometimes memory goes up, and then sometimes it frees up like a gigabyte of memory. This is specific to modded Minecraft. It'll free up like a ton of memory. That's when you can actually see when the garbage collector has actually run, because a bunch of data that has stopped being referred to, basically has no reference to it anymore, gets freed up. So memory use drops dramatically.
But if you had a primitive type such as like int x equals 5, then
that is going to be in the stack. So
and if you change that 5 to a 6, you're just gonna on the stack directly change.
yeah, it's going to just say, hey, instead of 5, you're going to store 6. Yep.
And with the S example, if after those 2 lines I said, system.out.print S, it's gonna print out
It's going to print out what's in here.
Okay.
Yep. Samantha asked a question about constants. So a constant is basically just any number that you apply directly. Sometimes depending on how they're used, you cannot even sometimes refer to them as magic numbers. So a constant. A constant can also be stored in a final variable. So say private int final enterprise equals 1701. So I would say this instance of enterprise is a constant, because it is just a value that will never change. But to refine our definition, this is the constant, while this is still technically a variable. Does that give you an idea of what the constant may be, depending on how it's used? Yes, a literal and a constant are terms that probably could be used interchangeably. So a constant, constant is, like the term implies, unchanging. Awesome. Any last questions in our last couple minutes before we probably, I don't know who else may have this room after us, but we do just have a couple minutes left. Any last questions we want to ask? Yes.
We go over a feeling with Louise.
Okay, event handling. So I can't say I know very much about how event handling happens on GUIs, but it is because it is very much kind of a black box. It's something I cannot look into very deeply. But basically we say, hey, but basically something inside as we interact with our GUI basically changes a state within it that says, hey, this thing changed, this event happened. So like, say if we have an action listener, I'm gonna call it, say if we have this action performed method and whatever class, E as in the action event. this and say whatever class this was in, it was registered as the action listener. It would say anything that is listening to to this like specific action should be called. So the action event is created and it comes back to code that we've written to handle that specific event. Again, it is a pretty black box. So I can't speak to the specific way that happens. You'll learn more about events in CS 3500 as you write code that explicitly relates to basically you use a different GUI format. Yeah. All right, it is 2 p.m. I'm going to end the recording so that it can finish processing so I can post it. And then but this session, I'm going to basically just say this session is over. Thank you guys for coming. I do have one more session tomorrow at the same time, 12:30. It is Zoom only. The link has been posted on the Piazza announcement that I made as a reminder this morning. Thank you, guys.